study, and also some other factor. For example, probably in getting my data or in measurement of my data, it is easier for me to measure weight than body surface area, and I think weight is easier in measurement, so probably I will still leave weight in my model where I will drop body surface area. There will be need to drop one of these two. So let's see that. So the VRF value are fairly large. For instance, for 8.42, which is weight, the coefficient has its variance inflated 8 times than what is supposed to be. So let's make some discussion on some of these results that we have gotten earlier. The VRF for weight indicates estimated coefficient of weight is inflated by 8.4 because weight is highly correlated with at least one of the other predictor in the model. Let's look at that to confirm this. Let's look at this. Weight is correlated with age. Weight, let's look at it, is correlated with the age, and body surface area. Okay, weight is correlated with age, and let's look at it this way. Weight is correlated with the body surface area. It's also correlated with pulse. So you can see we are having issue with weight. This is multicollinearity. Weight is correlated with the body surface area. Weight is correlated with pulse. So let's assume we are dropping body surface area. So we're now having weight being correlated with pulse. So let's go down. So weight is highly correlated with at least one of the other predictor in the model. So that's showing where we are having problem of multicollinearity. Also, the variance inflated factor for pulse indicates the estimated coefficient of the exponential coefficient of pulse is inflated by 4.42 times higher. So to remove one of the correlated independent variable is suggested. So there is need for us to remove. We've already suggested removing body surface area. So body surface area and weight is marginally correlated also. We can choose to remove one of them since theoretically they are both similar factors. So we've suggested removing body surface area, and also the choice of one or two to remove depend on the researcher choice, as was said earlier. Say which of the variable is most interest, easily and available and measurable. Also, from the correlation matrix, pulse seems to be fairly correlated with age, weight and stress. We may consider removing the predictor pulse. So let's look at the correlation matrix we are talking about. So let's look at pulse. Pulse is correlated with age, is correlated with weight, is correlated also with body surface area, and correlated also with what? Duration. Most importantly is having the highest correlation with age and weight. So there are two variables here that has been suggested to be removed. Body surface area is suggested to be removed, and also pulse. So let's look at what we have now. So let's look at the new model we have. We've removed body surface area and we have removed pulse. So when we have the analysis, let's look at our R square. Our R square is still 0.999. So which is not different from when we have body surface area and pulse was there, which shows that body surface area and pulse, they are providing redundant information about Y. They are useless, they are redundant. So despite even removing them from our model, we can see that our R square we still have 0.999. So we seem not to have lost much by dropping these two variables. So let's look at our ANOVA. Still looking at our ANOVA, so our model can still explain 555 out of the 560 total sum of regression. Initially we are having 3, though there's a little bit increase in the residual here, just very minute. We are having 3 point something, now we are having 4.5. So we still have a very huge sum of square regression, and still our model is still statistically significant. Let's look at the individual independent variable after we have removed the ones that are redundant and they are causing multicollinearity. We have our age is still significant, weight is significant, duration though not significant, but they are having a very good contribution to the model. So what do we have here? Sorry, the resulting variance inflicted factor, we are having 1.47, 1.23, 1.20 and 1.24. That means the variance inflicted factor after we have removed body surface area and also we have removed pause, we have to check the variance inflicted factor again. So we now find for age all our variance inflicted factor at this point, they are closer to 1, so we have nothing to worry about, and our half squared value is still very large, and our model in general is statistically significant as we have before. So what we have been able to do successfully is by the variance inflicted factor to have able to check at the models, at the independent variables, whose coefficient and whose are the causes of multicollinearity, and having removed them, we have our analysis, and the result of analysis is as good as what we have before removing these two independent variables. So I believe you have learned one or two things to what we have done in the class earlier before this, so you can check some of this material here for the reference for the work. So I wish you the very best. Thank you.